Welcome to my YouTube channel, dear student. Today I am going to solve some examples based on the rule number 1. In previous video, I have explained about the non-exact differential equation, integrating factor, how to find the integrating factor, working rule to solve the examples on non-exact differential equation to exact differential equation. So that part we have covered in previous video. So you can see my previous video for understand the concept of non-exact differential equation to exact differential equation. So today we'll solve some example based on the rule number 1. The rule number 1 is if the differential equation is homogeneous differential equation, then integrating factor is equal to 1 upon mx plus ny. Now already we know that homogeneous differential equation means the degree of each term in the differential equation must be same. Then we say that it is homogeneous differential equation. Now consider this example: x square y minus 2xy square dx minus in bracket x cube minus 3x square y dy equal to 0. Now if we observe the degree of this term, power of x is 2, power of y is 1, means degree is 3 here. Here power of x is 1, power of y is 2. And if you consider the total term, you will get the degree is 3 here. The power of x is 3, so degree is 3 of this term. Here the power of x is 2, power of y is 1, means degree of this term is 3. So each and every term has degree 3 here. This means this is homogeneous differential equation. In this case, you have to use the integrating factor 1 upon mx plus ny. Before finding the integrating factor, you have to check whether the given differential equation is exact or not. So first write down the given differential equation in the form of m dx plus n dy equal to 0. So now take this negative sign inside of this bracket, automatically the sign will get changes. So you will get the given equation in the form of this x square y minus 2xy square dx plus minus x cube plus 3x square y dy equal to 0. Compare with m dx plus n dy equal to 0. You will get m equal to x square y minus 2xy square, n equal to minus x cube plus 3x square y. Differentiate this m partially with respect to y. So here you will get, so derivative of y is 1, so you will get only x square term here. Derivative of y square is 2y. 2y into 2x, it becomes 4xy. So del m by del y, you will get x square minus 4xy. Now n is x minus x cube plus 3x square y. Differentiate n partially with respect to x. So derivative of x cube is 3x square and negative sign as it is. Derivative of x square is 2x. 2x into 3 into y. So you will get 6xy. Now if you observe del n by del x and del m by del y, they are different. This means given differential equation is not exact. And we also know that the given differential equation is homogeneous. Then we can use the integrating factor 1 upon mx plus ny. Now substitute m and n here. M is x square y minus 2x y square into x plus n is minus x cube plus 3x square y into y. Now multiply this x to this bracket, y to this bracket, and see what will you get. 1 upon x into x square y, you will get x cube y, minus x into 2xy square, 2x square y square, plus minus minus x cube into y, x cube y, plus 3x square into y, it will give 3x square y square. Now here x cube y minus x cube y get cancelled, only remain minus 2x square y square plus 3x square y square. So it will be x square y square in the denominator. So you will get integrating factor 1 upon x square into y square. Now after getting the integrating factor, you have to multiply the integrating factor to the given differential equation so that it becomes exact. So let's multiply this 1 upon x square y square to the given differential equation. So 1 upon x square into y square, this is the given differential equation which is equal to 0. Now multiply this 1 upon x square y square to each and every term in this bracket. So you will get 1 upon y minus 2 upon x dx plus minus x upon y square plus 3 upon y dy equal to 0. So let's call this as a new differential equation 1. Now compare this new differential equation of our standard form m dx plus n dy. Instead of m and n, we're using m dash and n dash because already we have used m and n. So let's consider it will be m dash of dx plus n dash of dy equal to 0. So here m dash is 1 upon y minus 2 upon x and n dash is minus x upon y square plus 3 upon y. So we got m dash 1 upon y minus 2 upon x, n dash is minus x upon y square plus 3 upon y. Now differentiate this m dash with respect to y. So derivative of 1 upon y is minus 1 upon y square. 2 is a constant, x is a constant, derivative of constant term is 0. Now differentiate this n dash with respect to x. So derivative of x is 1. So negative sign as it is. So we'll get minus 1 upon y square. 3 is a constant, y is a constant. So derivative of constant term is 0. Now you can observe here del n dash by del x, del m dash by del y are same. This means the new differential equation 1 is exact. Now it becomes exact after multiplying the integrating factor. The new differential equation becomes exact. Now you can find the general solution. So general solution is integration of m dash of dx plus integration of terms of n not containing x into dy equal to c. Here we are taking y as a constant. Now put m dash and m dash here. So integration of m dash is 1 upon y minus 2 upon x dx plus. Now here we are taking the terms of n not containing x. Now you can see here the terms n dash, which is a term here not containing x. So this is the only one term which is not containing x. So we'll consider only 3 upon y. So here integration of 3 upon y dy equal to c. Now separate this part, integration of 1 upon y dx minus integration of 2 upon x into dx plus integration of 3 upon y dy equal to c. Now when we are doing integration with respect to x, then obviously 1 upon y is a constant. You can take it outside. So you will get 1 upon y integration of dx. Now minus 2 is a constant, you can take it outside. So you will get integration of 1 by x dx plus 3 is a constant term, you can take outside. You will get integration of 1 upon y dy equal to c. Now take the integration of this. Integration of dx is x. Integration of 1 by x is log of x. Integration of 1 by y dy is log of y equal to c. Now this we can write x upon y minus 2 into log of x means it is log of x square plus 3 into log y means it is log of y cube equal to c. So this is the general solution of the given equation. Now come to the second question on rule number 1. Second question is x cube plus y cube dy by dx is equal to x square y. Now first write down the given differential equation in the form of m dx plus n dy form. So now you can shift this dx to this side. So you will get x cube plus y cube dy equal to x square y dx. Now shift these three terms to this side. So you will get x square y dx minus x cube plus y cube dy equal to 0. Now write down this equation in the form of m dx plus n dy. Now here is a negative sign, we'll take it in bracket. So you will get x square y dx plus minus x cube minus y cube dy equal to 0. Compare with m dx plus n dy equal to 0. Here m is x square y, n is minus x cube minus y cube. Now differentiate m partially with respect to y. You will get derivative of y is 1. So you will get only x square here. Now differentiate n partially with respect to x. So derivative of x cube is 3x square, and this negative sign is as it is. Y is constant, derivative of y cube is 0 because of derivative of constant term is 0. Now you can observe here del n by del x and del m by del y are different. Means del m by del y is not equal to del n by del x. This means the given differential equation is not exact. Now check whether it is homogeneous or not. Now if you see the degree of this differential equation, power of x is 2, power of y is 1, means degree of this entire term is 3. Power of x is 3, means degree is 3. Power of y is 3, means degree is 3. Each and every term has power 3, means it is homogeneous differential equation. Then the integrating factor is 1 upon mx plus ny. So put m and n here. So 1 upon x square y into x plus n is minus x cube minus y cube into y. Now multiply this x to this bracket, y to this bracket. So you will get x into x square y. It will be x cube y minus multiply y to this bracket minus x cube y minus y cube into y. So it will be y raised to 4. So x cube y minus x cube y get cancelled. So only remain 1 upon minus y raised to 4. That means minus 1 upon y raised to 4 is the integrating factor. So here we'll get the integrating factor minus 1 upon y raised to 4 after cancelling these two terms. Now next step is multiply this integrating factor to the given differential equation. So this is the given differential equation. Multiply 1 upon minus y raised to 4 to this differential equation so that it becomes an exact differential equation. Let's see that part. So here we are multiplying minus 1 upon y raised to 4 to the given differential equation. So this is the given differential equation. So after multiplying minus 1 upon y raised to 4 to this bracket, so you will get minus x up y square, x square upon y cube dx plus x cube upon y raised to 4 plus y 1 upon y dy equal to 0. Now compare this with m dash of dx plus n dash of dy equal to 0. So m dash is minus x square upon y cube, n dash is x cube upon y raised to 4 plus 1 upon y. Differentiate m dash with respect to y. So you will get 3x square upon y raised to 4 and del n dash by del x will be 3x square upon y raised to 4. This means del m dash by del y, del n dash by del x are equal. The new differential equation is exact and the general solution becomes integration of m dash of dx plus the integration of terms of n dash not containing x into dy equal to c. Now put m dash is minus x square upon y cube dx plus the terms of n dash not containing x. Now see the term n dash is x cube upon y raised to 4 plus 1 upon y. Here which is the term not containing x? So there is only one term 1 upon y which is not containing x. So we'll write that term only here. So integration of 1 by y dy equal to c. Now take the integration of this. So integration of minus x cube upon y raised to 3 into dx. So obviously y cube is a constant. You can take it outside. Negative sign also you can take it outside. So minus 1 upon y cube into integration of x square dx plus integration of 1 by y dy equal to c. So integration of x square is x cube upon 3 plus integration of 1 by y dy is log of y equal to c. So this is same as minus x cube upon 3y cube plus log of y equal to c. So this will be the general solution of second question. Now this is a question number 3. Solve x into x plus y into dy equal to y square into dx. Now I want a solution from you. You have to solve this question and comment your answer in comment box. Thank you so much. Now come to the rule number 2. If the differential equation of the form f1 of x into y into y dx plus f2 of xy into x dy equal to 0, then the integrating factor is 1 upon mx minus ny. So this is the integrating factor when we have the differentiable equation of this form, f1 of xy into y dx plus f2 of xy into x dy equal to 0. Now what is the meaning of this f1 of x into y? So there is a function which is the product of the terms x and y into y is there. Similarly, f2 of xy means there is a function which is a product of x into y, then into x is there. Then this kinds of differential equation is there, then you can use the integrating factor 1 upon mx minus ny. Now obviously this is non-homogeneous differential equation. We can consider it. So let's see the example based on this. So first question is solve 1 plus x into y dx plus in bracket 1 minus xy into x dy equal to 0. Now you can see here this is a first function f1 of x into y dx plus 1 minus xy into x dy. This is our standard form of the f1 of xy into y dx plus f2 of xy into x dx equal to 0. Now compare this given differential equation to our standard form m dx plus n dy equal to 0, where m is 1 plus x into y, n is 1 minus xy into x. Now multiply this y to this bracket, x to this bracket, so you will get y plus xy square. Here n equal to x minus x square y. Now differentiate this m partially with respect to y. So here you will get the derivative of y is 1, derivative of y square is 2y into x, so it will be 2xy. So del m by del y is 1 plus 2xy. Now differentiate n partially with respect to x. Derivative of x is 1, derivative of x square is 2x into y as it is. So you will get del n by del x equal to 1 minus 2xy. Now obviously you can see here del n by del x and del m by del y are not equal. This means the given differential equation is not exact, but it is of the form of f1 of xy into y dx plus f2 of xy into x dy equal to 0. Then we can find the integrating factor. Integrating factor is equal to 1 upon mx minus ny. Just put m and n here. M is y plus xy square. This x will remain as it is. Minus n is x minus x square y into y is as it is. Now multiply this x to this bracket, y to this bracket, so you will get xy plus x square y square minus xy plus x square y square. Xy get cancelled, so only remain here 1 upon 2 x square y square. So this is the integrating factor of the given differential equation. Now multiply this integrating factor to the given differential equation so that it becomes exact, and we'll find out the general solution. So we got integrating factor 1 upon 2 x square y square. Multiply this 1 upon 2 x square y square to the given differential equation. So this is a given differential equation. So after multiplying this 1 upon 2 x square y square to this bracket, you will get the terms in bracket 1 upon 2 x square y plus 1 upon 2x into dx plus 1 upon 2xy square minus 1 upon 2y dy equal to 0. So this is a new differential equation. Now compare this new differential equation with our standard form m dash of dx plus n dash of dy equal to 0, where m dash is here 1 upon 2x square y plus 1 upon 2x, n dash is 1 upon 2xy square minus 1 upon 2y. Now differentiate this m dash with respect to y, n dash with respect to x. So you will get del m dash by del y is equal to minus 1 upon 2 x square y square. Similarly here differentiate n dash with respect to x, so you will get minus 1 upon 2 x square y square. Both the terms are equal. This means the equation, this equation 1 is exact, and the general solution is integration of m dash dx keeping y constant plus integration of terms of n not containing x dy equal to c. This is a general solution. Now put m dash and n dash here, but n not containing x term. So integration of 1 upon x square 1 upon 2 x square y plus 1 upon 2x dx plus not containing x in the term of n is minus 1 upon 2 y dy equal to c. So integrating each and every term here with respect to x, so you'll get integration of 1 upon 2 x square y dx plus integration of 1 upon 2x dx minus plus minus become minus integration of 1 upon 2 y dy equal to c. So integrate this term with respect to x. So 1 upon x square is there, so integration of 1 upon x square is minus 1 by x plus integration of 1 by x is log of x, 1 by 2 is as it is. Similarly here 1 by 2 is a constant, you can take it outside. Integration of 1 by y dy is log of y equal to c. Now try to simplify this. You can take 1 by 2 outside from this three terms and you will get something like this, minus 1 upon xy plus log x minus log y equal to 2c. But 2c is a constant term, we can write it as a c dash